Thank you very much, Ash. That was an excellent start for me to carry on from. So what I'm looking at is also developing an aptamer, but looking at specifically targeting them to mycotoxins. So, brief overview of my work. It will be a novel aptamer, hopefully. Mycotoxins which have originated from the Fusarium species and looking at the family of the tritoacines, so specifically the T2 and the HT2 toxin. The method I'm using is also a Zelex method, however, it's a little bit of a variance because it's a brand new Zelex method called Capture Zelex. This basically method uses a solid support, in this case trap-avidin-coated magnetic beads, which sort of within the reaction supply a support where the primers and the library can bind onto. Now the way that works is the primers are coated with biotin, and so I'm using the very strong bond between the strap-avidin and the biotin to create sort of that set and where the aptamer will sit onto. The first part of my work has been primarily around optimizations, basically because Capture Zelex is such a new method, there's not a lot of work done around it yet. So I want to be 100% certain and confident that the aptamer I create is indeed specific to the target. A little bit of an overview of the two toxins I am looking at. So mycotoxins are secondary metabolites from the fungal species. You can find them in spices, cereals, dried foods, nuts, coffee, cocoa, oilseeds, fruits, meat and dairy products. So there's a very huge variety of food products where you can actually come across these toxins. There has been established that both these toxins have a potential risk to human and animal health, but further investigations into this are required. The way their toxic effect works within a system is that they inhibit the synthesis of proteins, they inhibit the mitochondrial functions, and also have an immunosuppressive and cytotoxic effect. Recently, the EFSA concluded that although there is a daily intake of both these toxins in human, the data shows that the overall exposure is in the tolerable daily limits for the current times. However, I want to point out that we are looking into a sort of different types of future where we are looking at possible climate changes and also changes in dietary habits. So the outlook could very well be that we will see an increase in growth of fungal species within our crops, which could then again have an increasing effect on the appearance of mycotoxins. And also the change in dietary habits. There has been sort of within yesterday definitely and past talks hinting on that we are moving away from meat consumption because it's unsustainable, eating more grain or another substitute, and indeed there we could see an increase in intake of T2 and HT2 toxins. These are images of my three target molecules. So the first one is DON, which is in the same family as both T2 and HT2. Now, I have images of these printed out above my desk at home, and I've been staring at them for so long now, all I can see is 3 mice. Maybe you can see it as well. There's a head structure on the top, then the body and the length of the tail determines the molecule. So that's the way I just see them now. Interestingly enough, if you are interested, the LD50 value for T-toxin in mice has been established to be 3.8, and in HT2, 5 milligrams per kilogram. So indeed, if you look at the molecule themselves, they are highly toxic. So optimizations, I'll run through this very briefly. I've been looking at changing the variance within my reactions. I've been setting up reactions by which I use the biotinylated primers with my beads, but then also non-biotinylated primers to see the effect this has, making sure that no non-bound primers or library could attach to the beads and therefore create a non-specific aptamer. So far it hasn't gone that well, I'm afraid to say. I'm ending up seeing continuously throughout my PCR reactions that the non-biotinylated primers still attach to the beads non-specifically. I have been in touch with the manufacturer and they tell me that can indeed occur. So I'm looking into different ways of reducing this binding specificity. I've been trying various washing steps, various drying steps as well. Now recently, and I would like to thank at this point my fellow lab technician who gave me the idea of using ethanol within the solution to stop this non-specific binding, and it's going very well at this point, so I am very happy. So my future work and outlook hopefully will be to continue the optimization, finally getting around to actually selecting an aptamer, and then also to select it against both my targets. So at this point, thank you very much for your attention, and would like to thank both of us, the committee, for the opportunity to present today. Thank you.
Thank you.